Hello class, this is Mr. Martin and I'm going to be working a problem for you today. We said our homework was pages 83 to 85, and from that I'm going to choose problem number 20. And these problems we're asking you to figure out how to make the solution. How do you make the solution? And it gives you the solution. It tells you there's 250 cubic centimeters of 0.0500 molar strontium silicon fluoride. Okay, so like we said in class, we're going to start with the molarity. So on just what it says, I'm going to write it out what we're looking to do. Just to clarify, we're going to go from our molarity to grams. So we know how to make this thing. We know that there's 250 cubic centimeters. We just don't know how many grams of this stuff to use. So that's what we're going to figure out. And again, we start with our molarity. Moles, 0.0500 moles of this compound. And in this compound, moles per decimeter cubed. Okay, so there we have it. We wrote it out the long way using the correct units, moles per decimeter cubed. The reason why we do that is so that we can see the moles. That's what we need to go to first. We can't go directly to grams. We have to go to moles. We said in class, how do we do that? Well, we need to multiply our molarity times our volume. And here's our volume, 250 cubic centimeters. Let me convert it because it has to be in decimeters cubed. We said in class today, 250 centimeters cubed. How do we get to decimeters cubed? Well, you must move the decimal to the left 3 spaces, so it becomes 0.250 decimeters cubed. Very important, very important. So now that I have that, I'm going to multiply by this volume, 0.250 decimeters cubed. Once it's set up like this, you can see that your units cancel out, the decimeters cubed are gone, and I'm left with moles. So now I just perform the math, I multiply 0.0500 times 0.250, and I end up getting 0.0125 moles of this compound. Alright, so let's talk about this really quick. There's 3 significant digits here, and there's 3 here, so I need to make sure I have 3 significant digits here. The 1, 2, 5 are significant, and I use those. There we go. We're all set. Now we have moles, and now we have to get to grams. Moles to grams, in the class we would say we need to use the periodic table. So that's what we're going to do. I'm going to use the periodic table. So I have this new sheet to figure that out. So I use the periodic table because I want to find out the molecular mass of this compound. And to do that, I break it down. So there's 1 strontium, and that strontium is 87.6 grams per mole. And so if I multiply 87.6 times 1, that gives me 87.6 grams per mole total. Alright, and then for the silicon, there's only one of them, and for each one, it's 28.1. And again, I multiply by the number of atoms, and there's only one, so I multiply 28.1 grams per mole. And then for the last one, for fluorine, there are 6 of them, 6 fluorines. And each one of those is 19.0 grams per mole. And if I multiply 6 times 19, I end up with 114. Alright, so all you have to do now to find the total molecular mass is add these all up, and it gives me a 229.7 grams per mole of this compound. Alright, so now I have the molecular mass, and I need to go back and change my moles to grams. So I'm going to take that with me. So I'm going to rewrite this over here. I have this whole setup. I have the moles, 0.0125 moles of strontium silicon fluoride. All over 1. Always put it over 1, anything over 1. And then I need to multiply by the molecular mass. I want the grams in the numerator and the moles in the denominator so I can cancel the moles. Always unit driven. Always unit driven. Don't be a unit hater. Grams of this strontium silicon fluoride. There's 229.7 grams in 1 mole of this stuff here. So then this cancels out with this, and I'm left with grams, and then I get my answer. And it should be 2.87 grams of this compound, strontium silicon fluoride. And there we have it, our answer. And remember, it's a couple things. It just depends on how you round, and then this could be just a slightly different, but not too much. But you'll see it a couple variances. Just be very careful when you are rounding and using significant digits, and that should be it. Hopefully that helps you out and answers your questions. I hope that you're able to finish your homework and get these done so it's not too much trouble. I'm going to make a little screencast of percent composition, so I'll talk to you soon.